Remember your first bicycle? The thrill of riding down the sidewalk, the wind in your hair, it's a vivid memory, a snapshot of childhood. But how does our brain hold on to these moments? How do fleeting experiences become lasting memories? Our brains are constantly at work, weaving together a tapestry of our lives. Think of your brain like a vast library. Each memory, from the taste of your favorite meal to the sound of a loved one's laughter, is a book carefully stored on its shelves. Some memories are clear and easily accessible, like frequently borrowed books. Others are tucked away in the back corners, waiting to be rediscovered. Our brains are incredible organs capable of storing a lifetime of information. From the mundane to the extraordinary, our memories shape who we are. They provide a sense of continuity to our lives and connect us to our past. But memories are more than just stories we tell ourselves. They are physically etched into the very structure of our brains. Let's delve into the fascinating world of neuroscience and explore how our brains create and preserve these precious memories. Imagine a bustling city with countless buildings connected by a network of roads. That's a lot like your brain. The buildings represent specialized cells called neurons, and the roads are the connections between them called synapses. Every time you experience something new, a new pathway is formed in this intricate city. Memories aren't stored in a single location. Instead, they are spread throughout the brain, like pieces of a puzzle. When you encounter something that triggers a memory, these scattered fragments are reassembled, bringing the experience back to life. But how do these connections actually form? It's all about electrical and chemical signals. When you learn something new, neurons fire electrical impulses across synapses. This repeated activation strengthens the connections, making it easier for signals to travel along that pathway in the future. Imagine walking through a field of tall grass. The first time is difficult, but as you repeatedly walk the same path, a clear trail emerges. Similarly, the more you recall a memory, the stronger the neural pathway becomes, making it easier to access. Let's delve deeper into the fascinating world of neurons and how they contribute to memory formation. Imagine these neurons as tiny messengers, constantly sending and receiving information through electrical impulses. When we encounter new information, these neurons light up, creating a network of activity. Think of it like a relay race. When you learn something new, the information passes from one neuron to the next, like a baton being passed from runner to runner. The more times the baton is passed, the smoother and faster the handoff becomes. But not all memories are created equal. Some experiences are easily forgotten, like what you had for breakfast last Tuesday. Others, like your first kiss, remain vivid for years to come. This difference in memorability is partly due to the role of a seahorse-shaped structure in the brain called the hippocampus. The hippocampus acts like a temporary storage unit for new memories. It receives information from various sensory areas of the brain and begins the process of consolidation, transferring those memories to long-term storage in other brain regions. Gap 3S. Beyond the biological mechanics of neurons and the hippocampus, emotions play a pivotal role in how memories are formed and retained. Think about the most impactful moments in your life, the joy of a graduation, the sorrow of a loss, or the thrill of an adventure. These experiences are etched into our memories not just because of the events themselves, but because of the emotions they evoke. When we experience something emotionally significant, our brain releases chemicals like adrenaline and cortisol. These chemicals act as a highlighter, marking the memory as important and enhancing its consolidation. This is why emotionally charged events are often remembered more vividly and for longer periods. Imagine your brain as a scrapbook, where each significant emotional experience gets a special decorated page. The more intense the emotion, the more elaborate the decoration. This emotional imprint helps us recall these moments with greater clarity and detail. So the next time you find yourself overwhelmed with emotion, know that your brain is busy creating a lasting memory. It's these emotional imprints that add color and depth to the story of our lives, making each memory unique and meaningful. Gap 3S. We've all experienced the grogginess of sleep deprivation and its impact on our ability to think clearly. But did you know that sleep plays a crucial role in memory consolidation? While we sleep, our brains are hard at work, replaying the events of the day and strengthening the neural connections that form memories. Think of it like transferring files from a computer's temporary memory, or RAM, to the hard drive for long-term storage. During sleep, the hippocampus reactivates the neural patterns associated with new memories, transferring them to the cortex for more permanent storage. Sleep deprivation, on the other hand, is like leaving those files stuck in RAM. Without adequate sleep, our brains struggle to consolidate memories effectively, leading to forgetfulness and difficulty recalling information. So, the next time you're tempted to pull an all-nighter, remember that a good night's sleep is essential for a sharp mind and strong memories. Your brain will thank you for it. Thank you for joining us on this journey through the fascinating world of memory. We hope you enjoyed learning about how our brains remember and store information. Now we'd love to hear from you. Please leave a comment below and share your most unforgettable experience. Don't forget to like, share, and subscribe for more intriguing content. Until next time, keep those memories alive.